Here's our new MQTT PoE Smart Light. The hardware was developed by Tom Frobase over at Kit Parts, and the software was developed by us over here at Mr. IoT. This is one of the many pieces of hardware that Tom and us have worked on together over the past several years. The interesting thing about this one is that most of it uses off-the-shelf hardware. There is some custom PCB for the 4 internally powered status inputs, and this version of it actually has a stack light that's connected to it. This is a 24 volt 3 light stack light, and if you notice, all of this is running off of the PoE. So this PoE switch here is providing 48 volt power, which is then internally dropped down to 24 volts to power the inputs and also to power the light. Also, we have just a simple prox switch connected into it so we can demonstrate how that is working later. The screen is displaying right now the count of the number of rising edges on the inputs, and then on the right side we're going to show the status of the lights. Before I get deep into the software, I just want to demonstrate. Right here is a little Node-RED dashboard that we developed. The top section shows the same as the left side of the display. The output status shows the same as the right side. And then we just have little buttons to be able to control the lights. Right? So I can turn on the green light. I can turn on the yellow light. I can turn on the red light. And if you turn them all on, you get a party. So let me demonstrate how the inputs work right now and the theory behind why we use some of the libraries that we did. So here for this fan, if I turn on the fan, I have a magnet attached to the fan here, which triggers the sensor to send the signal, right? So you can see it counting in here. Now, the way that we're able to, because of the libraries that we're using, we're able to count the inputs at a very high rate. So you could use something like this to count the pulses on an encoder and not be limited by some of the Python logic that's running in the background. And I'll explain that in a minute. All right, so now if we move on to my screen here, everything here is running as a container. We have Node-RED running as a Docker container. This is where we have laid out all of our logic to interface with the hardware and MQTT, and built the dashboard as well. Then we have Battleship, which is our Python code that runs the logic internally, talks to the internal circuitry, the I/O, and the MQTT broker as well. Here we have our actual Mosquito broker that's receiving all these messages and sending them all over the place. And PyGPIOD library, that's an amazing C library, very low level to be able to interface with I/O and the hardware itself. The PyGPIOD library mitigates some of our issues that we might experience using Python as our scripting language. Moving on to the Node-RED flow. It's very basic. We're subscribing to a couple different topics on the Mosquito broker. We're parsing the data and basically displaying here the values of our input counters. On the output side, we're doing the same thing. We're parsing out the data and we're showing the status of the lights as well as giving control to the user over which lights to turn on. When these toggle buttons are switched, the message is then sent back to the MQTT broker and enacted upon by the hardware. What you can see here in the dashboard is the status of every single input as well as the lights. We're giving the user the ability to control the lights from here. And my colleague has a sensor connected to a fan which is monitoring the RPM of the fan itself. That's it for this video about our MQTT Power over Ethernet Smart Light. Thanks for watching. If you have any more questions about anything that we've shown, give us a shout. Mr. IoT.